In this section, we'll look at some ideas that relate to graph connectivity. So we're looking at, again, the idea of a graph is one where what's significant is connections among items, so connections among people, connections among locations, whatever it is in the problem. And we're going to look at how to find connections and how to find either paths or circuits. And we'll look at some specific types of paths and circuits here. So I've got two definitions up here, the definition of a path and a circuit. Again, both very intuitive intuitive definitions. A path just means that you can get from point A to point B. Notice I've got in there the idea of starting at A and ending at B. That's mostly just for us to think about this idea. It's mostly just to connect the dots for us. Realistically, when you're looking at a path in general, there's no concept of starting and ending unless it's a directed graph. So direction generally is not significant. So the idea of starting at A and ending at B is just kind of to get us visualizing what this looks like, that you can travel from A to B or from B to A. Of course, you can have similarly a path in a directed graph, which does have the sense of starting at one place and ending at another. Then a circuit would be a closed path. So it would be where you can start at one point, travel through some sequence of edges, and then get back to where you started. So that would be a circuit. And then of course we can have a simple path or a simple circuit, which just means it doesn't contain any edge more than once. And that kind of goes back to the definition of a simple graph, where we didn't allow multiple edges between a set of vertices. The same terminology kind of plays in here, where you're not allowing any edge to belong to this more than once. So you're not going to retrace your steps. So thinking back to the problem we started with at the beginning, the Königsberg Bridge problem, what the problem was looking for is a simple path or a simple circuit, depending on how you phrase it, that you don't want to recover or retrace your steps across any one of the bridges. So that would be a simple path or circuit. So having these terms in mind, we can also define what we call a connected graph. And this is exactly what you would expect it to be. It's a graph where all of the nodes are ultimately connected to each other through some sequence of edges. So a shorter way to say that is that there exists a path between every set or pair of vertices. In the graph. So you can start at any one point and find a way to get to any other point that you want to. If you cannot do that, then it's not connected. It's a disconnected graph. So here's a simple example. We have nodes like this, and then we draw some edges, some connections that look like this. You can very easily tell this is a connected graph. And really, just by looking at a graph, you can generally tell if it's connected or not, assuming it's small enough that you can see it all at once. If it's larger and more complicated, it can be easy to miss. But with the kind of graphs that we draw for our examples, you can kind of just tell by looking at it whether it's connected or not. One over here, just as an example of a disconnected graph, would be one like this, where you have a couple other nodes out here, and there's no connection, say, from D to B, right? There's no way to get there along any of the edges. So that's a disconnected graph. And for a disconnected graph, what might be interesting is to look at the connected components of it. So these would be the two connected components. So in other words, if you select just the nodes A, B, and C, those are connected to each other. So there's a subgraph there that's connected. And then D and E are also connected to each other. So you can think about the connected components. So if you're thinking about, for instance, like a network, a communication network like we looked at in the last section, you would want that to be a connected graph, because otherwise there might be two nodes that can't communicate with each other if it's disconnected. So you want it to be connected so that any two nodes can communicate. So that's the idea of a connected graph. is using the definition of a path to say that we can draw a path between every pair of vertices.